For over a century, the highways of America have been shaped by machines and men determined to move goods faster, farther, and more efficiently than ever before. Among them, one name quietly transformed the face of freight. A company that began not with grand ambitions, but with a simple question: what if trucks could be lighter, stronger, and faster? From rugged mountain passes to sprawling coast-to-coast highways, this story follows innovation born from necessity, challenges that tested both engineers and drivers, and a relentless drive to redefine transportation itself. It is a journey through mechanical ingenuity, economic pressures, and bold vision. A story where the road is never easy, but the possibilities stretch as far as the horizon. America's freight problem before Freightliner, 1900s to 1930s. In the early 20th century, freight transportation in the United States was dominated by the railroads. Lines stretched from Atlantic ports to inland factories and across the Great Plains to Pacific harbors, forming a mature system that had taken shape since the 19th century. For long-distance shipments and bulk commodities, railroads offered unmatched reliability and capacity. By contrast, motor vehicles were still in their infancy. Outside large cities, most roads were unpaved, poorly graded, and often impassable during heavy rains or winter snows. Bridges were too light for significant loads, and many rural routes were little more than mud tracks. Under such conditions, trucks were confined to local hauls and urban deliveries rather than serious long-distance freight. The first commercial trucks were little more than modified automobiles. They featured wooden cabs, chain-driven axles, and payloads of only a few tons. Breakdowns were frequent, parts were not standardized, and service facilities were rare. Pneumatic tires softened rides but punctured easily on rough roads. Fuel supplies outside towns were unreliable, forcing operators to carry extra cans. Maintenance was usually performed in the field, with drivers serving as their own mechanics. These limitations ensured that railroads remained the backbone of American freight, while trucks served a supporting role. The First World War provided the first large-scale test of motor trucks. The U.S. Army deployed thousands, and manufacturers like Mack and White developed sturdier models for military service. Convoys across rough terrain demonstrated the need for stronger frames, standardized components, and trained operators. Wartime use gave the truck industry credibility, but when peace returned in 1918, railroads quickly regained dominance. Their nationwide reach and capacity left little room for trucks beyond regional or short-haul work. The 1920s brought gradual change. The Federal Highway Act of 1921 committed funds to coordinated state road systems, the first step toward unifying America's patchwork of highways. By decade's end, paved routes connected major cities in the Northeast, Midwest, and along the West Coast. While most of the nation's 4 million miles of roads were still unpaved, improvements made longer truck hauls increasingly feasible. At the same time, mechanical advances strengthened frames, improved braking systems, and introduced more durable transmissions. Diesel engines promised efficiency, though gasoline remained dominant. By 1929, Department of Commerce data revealed significant trucking growth, particularly in agriculture and coastal trade. Farmers and regional distributors valued the direct service trucks provided. Still, railroads carried the bulk of the freight tonnage, retaining their position as the nation's commercial backbone. Trucks had become important, but still secondary. The Great Depression, beginning in 1929, reshaped the balance. With industrial production collapsing, freight demand fell sharply. Both railroads and truck operators suffered, but trucks showed resilience. Small carriers had lower fixed costs, could bypass terminals, and offered direct service. For perishable goods like produce and dairy, trucks proved indispensable. Even amid contraction, trucking-filled niches railroads struggled to handle efficiently. Even amid contraction, trucking-filled niches railroads struggled to handle efficiently. Yet regulation posed challenges. Each state enforced its own limits on size, axle weight, and licensing fees. A truck legal in one state might be banned in another. Tolls, permits, and inconsistent enforcement raised costs. Without national standards, coast-to-coast trucking was impractical, so most firms remained regional. In California and the Pacific Northwest, agriculture and timber economies demanded trucks capable of handling mountain passes, weak bridges, and long grades. Standard heavy models often failed, prompting operators to modify vehicles or experiment with lighter materials. These efforts hinted at a new design philosophy: efficiency over bulk. By the end of the 1930s, railroads still dominated long-haul freight, but trucks had carved out an indispensable role where flexibility and speed were decisive. Improved highways, sturdier vehicles, and the pressures of economic hardship expanded their use. On the West Coast, one determined operator was preparing to go further than modifications. He would build trucks tailored for regional needs. This decision would lay the foundation for Freightliner, Leland James, and the vision of a West Coast carrier, 1930s to 1940s. The Pacific Northwest in the 1930s was a region defined by rugged terrain, long distances, and industries dependent on natural resources. Timber, agriculture, and fisheries produced vast volumes of goods, but moving them to markets was difficult. Railroads dominated long-haul freight, yet their fixed schedules and terminal costs frustrated shippers. Though roads had improved since the 1920s, steep grades, wooden bridges, and narrow lanes still restricted truck size and weight. Into this environment stepped Leland James. Born in 1883 in Wisconsin, he moved west as a young man and entered the freight business when trucking was still a minor alternative to rail. In 1929, he founded Consolidated Freight Lines at the onset of the Great Depression. While many firms collapsed, his grew by focusing on short and medium-haul freight that railroads could not handle profitably. His company was lean, avoided rail's overhead, and provided direct service that prioritized speed and convenience. James differed from many entrepreneurs because of how he viewed trucks themselves. Most carriers simply bought standard models and modified them slightly. These vehicles were designed for the Midwest and East, not for the mountainous Northwest. Heavy frames and inefficient layouts reduced payloads and raised fuel costs. James recognized that lighter, more efficient trucks could transform operations. By the mid-1930s, Consolidated Freight Lines expanded across Oregon, Washington, and Idaho. James reinvested profits in equipment, but remained dissatisfied with conventional models. His mechanics began experimenting with lighter frames, aluminum panels, and improved configurations. These efforts went beyond routine maintenance. They reflected a new design philosophy rooted in efficiency. James argued that streamlined, lighter trucks could haul the same volume as heavier ones while burning less fuel and performing better on steep routes. This challenged conventional wisdom, which equated bulk with durability. But in the Northwest, where bridges imposed strict limits and geography dictated routes, efficiency was not only practical, but essential. He also understood trucking as part of a broader freight system. By offering reliable service to towns neglected by railroads, Consolidated built loyalty among farmers, mill owners, and small manufacturers. His fleet became a trusted link between rural producers and regional markets. By the late 1930s, James had proven that regional trucking could thrive through efficiency and adaptability. Yet, modifications only went so far. To achieve the balance he wanted, strength, weight savings, and cost efficiency, new trucks would have to be built. This realization set the stage for Freightliner. By the late 1930s, James had grown frustrated with Detroit-built trucks. Standard models were designed for flat terrain and bulk hauling, not for the Northwest's mountains and bridges. Consolidated's custom modifications, lighter frames, aluminum parts, aerodynamic tweaks, were effective but limited. James concluded that the ideal truck had to be built from scratch. In 1939, he established a dedicated workshop in Portland to design and build trucks for Consolidated's use. This was the beginning of Freightliner. These early vehicles emphasized lightweight aluminum construction, streamlined cabs, and cab-over-engine layouts that maximized cargo space while staying within length restrictions. The cab-over design proved crucial. By placing the cab directly above the engine, overall length was reduced, allowing longer trailers within legal limits. This practical innovation became a defining Freightliner feature. Initially, these trucks were exclusive to Consolidated, giving the company a competitive edge. Their sleek appearance and performance soon attracted attention from competitors, however, and James realized demand extended beyond his own fleet. Global events accelerated this transition. With World War II underway by 1939 and the U.S. entering in 1941, trucking gained new importance. Freightliner's lightweight, fuel-efficient designs aligned with wartime needs, though aluminum rationing limited output. Still, its reputation spread as a builder of efficient, modern trucks. By 1942, Freightliner had emerged from being merely a fleet workshop to a manufacturer with a distinct philosophy. Trucks should be designed for efficiency, tailored to real operating environments, and built without compromise. The foundation for post-war expansion was set. From these modest beginnings, Freightliner was born, a company that would eventually redefine freight transportation in America. Freightliner in the war effort. 1940s. When the United States entered the Second World War in December 1941, the transportation industry became a critical component of the national war effort. Railroads carried the bulk of wartime freight, but trucking played an increasingly important role in moving goods from factories to depots, ports, and military bases. For a young company like Freightliner, the war years provided both opportunities and restrictions that would shape its development. Freightliner had begun as an in-house project of Consolidated Freight Lines, building lightweight and efficient trucks tailored to the Pacific Northwest. By the early 1940s, the company's cab-over-engine designs had already proven their worth in regional freight service. Yet, with the declaration of war, civilian truck production across the nation came under strict regulation. The War Production Board prioritized materials like steel, aluminum, and rubber for military use, leaving limited capacity for private manufacturing. For Freightliner, which relied heavily on aluminum in its lightweight designs, these restrictions threatened to halt its progress just as it was gaining momentum. Despite these limitations, Freightliner managed to remain active during the war by adapting to new demands. The company supplied trucks to Consolidated's operations that were considered essential for transporting goods vital to the war economy. Agriculture, timber, and shipbuilding industries in the Pacific Northwest required reliable freight service, and Freightliner's vehicles were particularly well suited to these regional needs. Their lighter construction conserved fuel and allowed carriers to maximize payloads while staying within weight limits on bridges and mountain roads. Freightliner also benefited from the military's growing interest in efficient vehicles. While most of the U.S. Army's truck needs were met by established manufacturers like GMC, Studebaker, and Dodge, Freightliner's engineering innovations did not go unnoticed. The company's cab-over-engine layout offered compactness and cargo advantages that aligned with military priorities. Although Freightliner did not become a major supplier to the armed forces during the war, its designs influenced post-war thinking about how trucks could be built for efficiency rather than bulk. The war also reshaped the labor and production environment in which Freightliner operated. Materials were rationed, meaning the company had to innovate with whatever resources were available. Skilled workers were often drafted into military service, creating shortages in the labor force. At the same time, the demand for freight transportation surged, as shipyards, aircraft factories, and military bases across the West Coast required steady deliveries of parts and supplies. This environment pushed Freightliner to refine its methods, streamline production, and maintain reliability under challenging conditions. One of the defining characteristics of Freightliner during the 1940s was its ability to survive as a small but innovative manufacturer, while larger companies dominated the market. Firms like Mack and International Harvester focused heavily on military contracts, turning out tens of thousands of standardized trucks for the war. Freightliner, by contrast, remained regional and specialized, producing smaller numbers of vehicles but continuing to experiment with designs that emphasized fuel efficiency, lighter materials, and cab-forward layouts. This focus kept the company distinct at a time when most manufacturers concentrated on mass production. Another important outcome of the war years was the growing recognition of trucking as a whole. With railroads operating at full capacity, trucks became indispensable in bridging gaps in the logistics system. Military bases often relied on trucking firms for short and medium-distance deliveries, while agricultural producers used trucks to move perishables quickly to markets, feeding both civilian and military populations. These conditions validated the very principles that Freightliner had built its identity upon: flexibility, efficiency, and the ability to serve where rail could not. By 1945, as the war drew to a close, Freightliner had survived a period of constraint and transformation. It had not become a mass producer of military vehicles, but it had demonstrated resilience in the face of material shortages and shifting priorities. Just as importantly, the company had solidified its role as a builder of specialized trucks designed to meet regional needs. Its cab-over-engine design, which saved space and maximized cargo capacity, had become a recognizable hallmark on the highways of the Pacific Northwest. The war had forced Freightliner to prove that a small manufacturer could endure alongside larger rivals while holding fast to its engineering philosophy. The experience laid the groundwork for post-war expansion, when material shortages lifted and demand for efficient trucks exploded. Freightliner entered the late 1940s positioned not as a wartime giant, but as a company ready to grow in a nation about to experience a boom in freight transportation. Post-war highway boom and Freightliner's expansion, late 1940s to 1950s. The end of the Second World War created an environment in which American freight transport was reshaped. Returning servicemen, rising consumer demand, and years of deferred investment fueled an economic surge that demanded faster and more flexible distribution. Railroads still carried most freight, but their fixed schedules and terminal costs limited their responsiveness. Trucks, by contrast, could provide point-to-point service, and the improved road systems of the late 1940s gave them room to grow. For Freightliner, this was the moment when a regional manufacturer began to find national opportunities. Highway development was one of the most important drivers of change. Earlier efforts, such as the Federal Highway Act of 1921, had started the process of coordinating routes, but wartime restrictions slowed progress. After 1945, states resumed construction and upgrades, while the Federal Aid Highway Act of 1944 authorized a 40,000-mile interregional system that laid the groundwork for the modern interstate. Though large-scale construction would not begin until the mid-1950s, these improvements already created corridors where long-haul trucking became practical. Freightliner, with designs tested in the demanding terrain of the Pacific Northwest, was positioned to take advantage. The company's cab-over-engine models appealed to carriers that wanted maximum cargo space and lower vehicle weight. Leland James had emphasized efficiency in his designs, and this approach fit well with a post-war economy in which fuel, labor, and time determined profitability. Freightliner trucks were produced in relatively small volumes, but word of their durability and operating economy spread beyond the Northwest, attracting the interest of fleets in other regions. An important step came through the partnership with White Motor Company of Cleveland, Ohio. White was one of the nation's established truck builders with a broad dealer network. By distributing Freightliner vehicles through White outlets, the smaller company reached new markets without having to build its own national sales system. Many of these trucks were co-branded, carrying both the White and Freightliner names. For operators unfamiliar with the Oregon-based builder, the association with White provided reassurance, while Freightliner gained visibility far beyond its home territory. The design philosophy remained distinct. While Detroit manufacturers focused on heavy conventional models suited to flat terrain and bulk hauling, Freightliner concentrated on lightweight aluminum construction and compact cab-over layouts. These features were not only practical in the mountainous Northwest, but also attractive wherever weight limits restricted payloads or fuel efficiency was critical. Carriers found that Freightliner trucks could haul profitable loads with lower operating costs, an advantage as competition within regulated markets grew. The expanding post-war consumer economy reinforced these strengths. Rising household incomes and the growth of suburban communities created new demand for timely distribution of packaged goods. Supermarkets, wholesalers, and regional warehouses relied increasingly on trucks for daily deliveries. Railroads remained important for bulk commodities, but the new logistics of consumer goods favored flexible carriers. In this environment, Freightliner's reputation for efficiency gave it an edge, particularly for fleets adapting to just-in-time distribution models. Regulatory structures shaped the industry as well. Since the Motor Carrier Act of 1935, interstate trucking had been under the oversight of the Interstate Commerce Commission. Carriers were required to obtain operating authority, and competition was limited to those with established rights. While this framework restricted new entrants, it created stability for firms already in operation. Consolidated freight lines and similar companies benefited, and as they expanded their authorized routes, they required reliable, economical trucks. Freightliner was well-placed to meet this demand, supplying equipment tailored for regulated but growing freight businesses. Technological shifts added to the momentum. Although gasoline engines had long dominated, diesel engines gained acceptance in the post-war years due to their superior fuel economy and durability. Freightliner's lightweight designs paired effectively with diesel power plants, delivering long-haul savings that appealed to cost-conscious carriers. By the late 1950s, diesel engines were becoming the preferred option in American trucking, further aligning with Freightliner's emphasis on operating efficiency. By the close of the decade, Freightliner had moved beyond its origins as a regional experiment. It remained smaller than competitors such as Mack, International Harvester, or Kenworth, but it had secured recognition as an innovator. Its partnership with White expanded its reach, its design philosophy distinguished it from mass-market builders, and its reputation grew as highways extended and freight volumes increased. The company had not yet achieved dominance, but its foundation was strong, and the conditions of the 1950s positioned Freightliner to continue its rise in the decades ahead. Technical innovations, aluminum, cab-over, and weight efficiency, 1950s to 1960s. By the early 1950s, Freightliner had moved beyond its roots as a regional carrier's workshop. What began as Leland James's solution to the unique geography of the Pacific Northwest was becoming a recognized manufacturer with a reputation for building efficient, practical machines. The post-war years were defined by the expansion of highways, growing freight demand, and increasing regulation. In this environment, Freightliner's focus on lightweight aluminum, cab-over engine designs, and weight efficiency set it apart from its competitors. One of Freightliner's most important advances was its use of aluminum. While most manufacturers relied heavily on steel, Freightliner embraced lighter alloys for frames, cabs, and components. Aluminum reduced overall weight without compromising strength, a critical advantage in western states where bridges and roads imposed strict weight limits. A lighter tractor meant operators could devote more of the legal gross weight to cargo rather than the truck itself, improving profitability. Although aluminum was expensive and more difficult to fabricate, it quickly became central to Freightliner's reputation for building efficient trucks tailored to real-world conditions. Another defining feature of Freightliner's post-war identity was its early adoption of the cab-over engine, or COE, layout. Unlike conventional long-hood designs, the COE placed the driver directly above the engine. This dramatically shortened the tractor's length, allowing operators to haul longer trailers while staying within legal limits on total vehicle length. At a time when many states restricted the combined length of truck and trailer, the COE offered a clear economic advantage. Though drivers often complained about noise, heat, and rougher rides, carriers valued the ability to maximize cargo space. Over time, the tall, boxy Freightliner cabover became one of the company's most recognizable signatures. Weight efficiency extended beyond aluminum and cab design. Freightliner engineers refined chassis layouts, axle spacing, and component placement to minimize unnecessary weight and improve balance. Their trucks often featured modular construction, which made servicing easier and reduced downtime. Even basic attention to body shape hinted at aerodynamic thinking, years before it became common in the industry. These efforts reflected the same philosophy Leland James had championed decades earlier. Efficiency mattered as much as strength, and design should serve the operator's bottom line. The regulatory environment of the 1950s and 1960s made these innovations even more valuable. Federal and state governments enforced strict rules on vehicle dimensions, axle weights, and gross loads. A lighter truck could legally carry more cargo, while a cabover layout allowed longer trailers within the law. Freightliner marketed its products as solutions to these constraints, appealing directly to operators trying to compete under tight regulations. This approach distinguished the company from larger manufacturers still focused on conventional long hood designs, optimized for bulk hauling across flatter terrain. During this period, Freightliner also expanded its presence beyond the Pacific Northwest. Production partnerships and new distribution channels helped bring its distinctive designs to fleets across the country. Carriers seeking to maximize efficiency adopted Freightliner's aluminum and cabover models, while smaller operators valued the company's willingness to build trucks adapted to specific regional challenges. The squared-off cabover silhouette became an increasingly familiar sight on American highways, symbolizing a different philosophy of freight movement. Challenges accompanied these innovations. Aluminum fabrication required new tools and skills, adding cost to production. Some operators hesitated to pay a premium for lighter trucks, while many drivers disliked the COE layout for its lack of comfort and harder access to the engine. Yet for companies focused on efficiency and legal payload, the numbers outweighed the drawbacks. Freightliner proved that design could shift industry norms by emphasizing profitability rather than tradition. By the late 1960s, Freightliner had cemented its place as a leader in technical innovation. Its use of aluminum, its dedication to weight efficiency, and its commitment to the cabover design marked it as a company willing to challenge convention. In an industry dominated by long-established builders, Freightliner thrived by offering practical solutions to the problems operators faced every day. These principles, lighter construction, regulatory compliance, and maximizing cargo capacity, defined the company's identity and positioned it for future growth. The 1950s and 1960s were not merely years of survival, but of definition for Freightliner. Its engineering choices reflected Leland James's original vision: trucks designed for efficiency in the real world rather than for prestige. This period established the company's enduring reputation as a builder of specialized, forward-looking machines and ensured that Freightliner remained at the forefront of the American trucking industry. The Interstate Highway Act and a New Era of Trucking, 1956 onward. In 1956, the American freight industry entered a new era with the Federal Aid Highway Act, signed into law by President Dwight D. Eisenhower. It authorized construction of more than 40,000 miles of limited-access highways, forming the interstate highway system. For trucking, this network was more than an infrastructure project. It was a revolution that redefined how goods moved and how manufacturers like Freightliner positioned themselves in the national market. Before the interstate system, trucking was expanding but constrained by geography. Long routes meant navigating narrow rural roads, congested town centers, and unpredictable state networks. Travel was slow, costly, and often dangerous. The new highways changed that. Standardized design, smoother grades, and broad lanes allowed for faster, safer, and more reliable movement. Distances that once took days could be covered in hours, making trucking a direct competitor to railroads in long-haul freight. Freightliner was well prepared for this transformation. Since its founding, the company had specialized in lightweight aluminum construction and cab-over-engine designs that maximized cargo within strict length limits. These attributes became more valuable as carriers expanded into cross-country operations. The interstate system allowed operators to exploit every advantage in payload and fuel economy, and Freightliner's trucks delivered both. The new environment also shifted customer expectations. Fleets now required trucks that could maintain higher speeds for longer stretches while remaining economical to operate. Freightliner refined its engineering accordingly, producing vehicles that balanced lightweight with durability. Its compact cab-over tractors, once seen as a niche solution for states with strict regulations, became fixtures on the new highways because they enabled greater cargo capacity without exceeding length restrictions. The rise of the highway system also reshaped distribution networks. Warehouses, terminals, and logistics hubs began appearing near interstate exits, repositioning supply chains to take advantage of reliable road access. Retailers expanded into suburban areas, while food distributors could ship perishable goods over greater distances. Freightliner's reputation for efficiency and adaptability made its trucks attractive to carriers operating in this rapidly evolving system. Regulation continued to influence design choices. Federal and state rules still imposed limits on gross weight and axle loads. Within those boundaries, Freightliner's cab-over trucks offered a strategic edge. While conventional tractors with long hoods gained popularity for driver comfort on extended routes, the compact COEs remained competitive because they maximized payload in length-restricted states. Freightliner's ability to tailor vehicles to both regulations and customer needs ensured its steady growth. The cultural impact of the highways was equally significant. Trucking emerged as a visible symbol of post-war progress, with freight vehicles becoming part of the national landscape. Drivers now traveled farther and faster than ever before, experiencing a new lifestyle built around long stretches of uninterrupted highway. Freightliner's distinctive aluminum rigs, recognizable for their clean lines and practical design, became part of this image. Machines associated with speed, efficiency, and the growing American consumer economy. Competition, however, intensified. Other manufacturers adapted quickly to the highway environment, offering models designed for long-distance hauling. Rising fuel costs and maintenance demands challenged all operators. Yet, Freightliner's consistent emphasis on lightweight construction and operational efficiency gave it an edge. Carriers seeking maximum profitability per mile found value in the company's approach, even as the industry adjusted to higher volumes and longer routes. By the late 1960s, the interstate highway system had begun to transform the geography of American commerce. The barriers between regional and national trucking blurred, creating coast-to-coast networks that rivaled railroads. Freightliner, once a regional builder tied to the Pacific Northwest, had grown into a national manufacturer, its trucks integral to the infrastructure-driven expansion of freight transportation. The Interstate Highway Act was more than legislation. It reshaped American logistics. It allowed trucking to fulfill its promise of speed and flexibility, turning highways into the arteries of commerce. For Freightliner, it created the perfect stage to showcase decades of innovation in aluminum construction and compact design. The company's ability to adapt to this new landscape cemented its role in an industry that had become central to the nation's economy. Out of asphalt and regulation, Freightliner's path to national prominence was secured, building the network, dealers, service, and operator loyalty, 1950s to 1970s. By the 1950s, Freightliner had established itself as a strong regional competitor, but to grow nationally, it needed more than engineering. For trucking companies, equipment decisions depended not only on machines, but on service, parts, and dealer support. A truck sitting idle for lack of parts was a liability. Freightliner understood that building a dependable dealer and service network would be as critical as designing efficient vehicles. Dealerships became the foundation. Most truck buyers of the era worked with independent dealers who carried multiple brands. Convincing them to sell Freightliner required more than pitches. The company provided training, factory backing, and a growing parts distribution system. Operators buying a Freightliner knew they wouldn't be stranded without support, a reassurance that built loyalty. The partnership with White Motor Company was central. White already had a widespread dealer network in the Midwest and East. By teaming up in the early 1950s, Freightliner gained access to those regions almost overnight. Trucks sold under the White Freightliner name opened doors to customers who otherwise might not have considered a West Coast brand. White benefited by offering modern cab-over tractors, while Freightliner gained credibility through established dealer channels. The White name carried trust, easing adoption of Freightliner's lighter designs. Service support reinforced this reach. Freightliner invested in mechanic training, service manuals, and centralized distribution of replacement parts. Dealers received technical updates and standardized repair procedures, vital in an era of frequent maintenance needs. By ensuring quick repairs, Freightliner gave fleets confidence that their trucks would keep moving. Driver experience also mattered. Early cab-over trucks often had cramped cabs and poor visibility. Freightliner improved ergonomics and introduced tilting cabs for easier maintenance. Better seating and layouts reduced fatigue, and operators noticed drivers preferred Freightliners. For carriers facing driver shortages, comfort became a selling point. By the 1960s, Freightliner's presence extended far beyond the Pacific Northwest. Aluminum construction gave its trucks lower weight, higher payloads, and better fuel efficiency. Fleets valued the savings, drivers valued performance, and word spread quickly. Freightliner became known not only for profit-friendly trucks but for reliable service. The interstate highway system, launched in 1956, accelerated these trends. Longer hauls demanded consistent nationwide service, and Freightliner, with White's network, was positioned to deliver. Confidence and support drove more sales, which in turn encouraged dealers to expand their commitment. By the 1970s, this infrastructure had matured. Dealers became long-term partners in fleet management and maintenance. Parts distribution was streamlined, training standardized, and service reliability turned into a core selling point. Even as rising fuel costs and regulations reshaped trucking, Freightliner's established network kept fleets loyal. Yet the 1970s brought serious headwinds. The oil shocks of 1973 and 1979 sent diesel prices soaring, making fuel efficiency as important as durability. Freightliner's lightweight aluminum construction gave it an edge, and the company began refining aerodynamics and weight distribution. Fleets demanded equipment that cut fuel use, and Freightliner's designs provided solutions. At the same time, new regulations complicated the landscape. The EPA imposed emission standards, often lowering fuel economy, while the DOT mandated upgrades in braking, lighting, and visibility. Compliance increased costs and engineering demands. Freightliner, supported by White's resources, adapted, but it required constant investment. Competition intensified. International Harvester emphasized durability. Kenworth and Peterbilt sold prestige and driver comfort, and Mack leaned on its reputation for toughness. Freightliner positioned itself as the efficient, lightweight alternative, an identity that resonated in a cost-conscious era. The broader industry also faced constraints from the Interstate Commerce Commission, which regulated rates and routes. Carriers hesitated to expand fleets under these conditions, though many pushed for deregulation, which would arrive in 1980. For Freightliner, uncertainty complicated forecasting, but it kept expanding its service and dealer base to be ready for future demand. Despite the turbulence, Freightliner pressed forward. It expanded manufacturing capacity, maintained parts availability, and leveraged White's distribution channels to reinforce its national presence. By the close of the 1970s, the company had weathered one of trucking's most volatile decades. The lessons were clear. Success required more than machines. It depended on trust, service, and the ability to adapt. Freightliner's reputation for lightweight efficiency and dependable support gave it resilience, but the challenges of the 1970s also revealed that bigger resources and deeper investment would be needed. The stage was set for the transformations of the 1980s, deregulation, corporate shifts, and a new era of growth. The Daimler-Benz acquisition and global integration, 1981 to 1990s. The early 1980s marked a pivotal turning point for Freightliner. By 1981, the company had established a strong position in North American trucking, particularly in the Western and Midwestern regions. Its focus on lightweight construction, aluminum-intensive cab designs, and reliable dealer support had created a loyal customer base. Yet the industry was entering a new era, characterized by deregulation, intensifying competition, and growing globalization. To strengthen its position, Freightliner sought strategic partnerships, ultimately finding a transformative opportunity in the form of Daimler-Benz, one of the world's leading commercial vehicle manufacturers. Daimler-Benz acquired a controlling interest in Freightliner in 1981, recognizing the potential to integrate a successful American brand into its global portfolio. The acquisition provided Freightliner with access to new technologies, expanded capital resources, and global engineering expertise. Daimler-Benz brought decades of experience in heavy-duty diesel engines, cab design, and vehicle efficiency. For Freightliner, this partnership meant more than financial backing. It offered the ability to develop trucks that could compete not only nationally, but also on an international scale. One of the immediate benefits of the acquisition was technological exchange. Freightliner engineers collaborated with Daimler-Benz counterparts to refine cab-over-engine designs, improve aerodynamics, and enhance powertrain efficiency. Diesel engine technology, already familiar to Freightliner in limited applications, was upgraded with European advances in fuel injection and turbocharging. These enhancements improved fuel economy and reliability, attributes increasingly critical to fleets operating under tighter cost pressures following deregulation. By adopting innovations from Daimler-Benz, Freightliner could offer vehicles that combined North American durability with European refinement. The acquisition also influenced production and manufacturing practices. Freightliner's Portland and Cleveland plants were modernized, incorporating assembly techniques and quality control standards derived from Daimler-Benz operations. Standardized processes improved consistency across the product line, while more precise engineering reduced downtime and maintenance issues for operators. The introduction of lean manufacturing principles and systematic testing protocols mirrored approaches used in Europe, raising Freightliner's efficiency and reputation in the marketplace. Global integration extended beyond technology and production. Freightliner gained access to Daimler-Benz's supply chain, benefiting from economies of scale in component sourcing. Key parts, from transmissions to braking systems, were procured using global contracts, reducing costs and ensuring availability for dealers across North America. At the same time, the company leveraged Daimler-Benz's established dealer networks in Europe and other regions, laying the groundwork for international sales and export initiatives. This strategic alignment transformed Freightliner from a regional brand into a player with global reach. The 1980s and 1990s also brought a focus on product diversification. Under Daimler-Benz's guidance, Freightliner expanded its range to include vocational trucks, long-haul tractors, and specialty applications. Cab designs were standardized to accommodate varying operational needs, from flatbed hauls to refrigerated transport. Aluminum-intensive construction remained a hallmark, but new materials and design techniques improved safety, aerodynamics, and payload efficiency. By offering a broader product line, Freightliner was able to compete effectively across multiple segments, responding to evolving customer requirements in a rapidly changing market. Operator support continued to be a central strategy. Freightliner's expanded dealer network now included training programs adapted from Daimler-Benz's European standards, covering maintenance, diagnostics, and parts management. Service reliability, already a hallmark of Freightliner's brand, was strengthened through centralized parts distribution and standardized technical manuals. Fleets could rely on consistent support nationwide, reinforcing loyalty at a time when customers faced more choices than ever before. By the late 1990s, the integration with Daimler-Benz had fundamentally altered Freightliner's trajectory. The company had become a globalized manufacturer, capable of competing with domestic and international rivals alike. Trucks produced during this period reflected a combination of North American ruggedness and European precision, offering efficiency, reliability, and operator-focused design. The acquisition positioned Freightliner to take advantage of new market opportunities, both within the United States and in emerging international markets. The Daimler-Benz era demonstrated that success in trucking required more than strong products. It demanded strategic partnerships, technological adaptation, and global thinking. By aligning with one of the world's leading commercial vehicle manufacturers, Freightliner moved beyond its regional roots to become a company capable of shaping the future of long-haul and vocational trucking worldwide. The 1980s and 1990s set the stage for decades of growth, innovation, and a fully integrated global presence that would define Freightliner in the 21st century. Product diversification, medium-duty and specialty trucks, 1980s to 1990s. By the 1980s, Freightliner had solidified its reputation as a leader in heavy-duty long-haul trucking, particularly following its integration with Daimler-Benz. However, growth opportunities lay beyond the traditional tractor-trailer market. Fleets increasingly demanded vehicles that could serve specialized applications, handle urban routes, and operate efficiently in medium-duty segments. Recognizing this, Freightliner pursued a strategy of product diversification, expanding its offerings to include medium-duty trucks and specialty vehicles designed for vocational purposes. Medium-duty trucks filled a critical gap between passenger-style delivery vehicles and full-size long-haul tractors. These trucks were designed to provide greater maneuverability, fuel efficiency, and operational flexibility without sacrificing payload capacity. Urban and regional delivery companies, municipal service fleets, and utility operators required vehicles that could navigate city streets, access tight industrial sites, and perform consistently under frequent stop-and-go conditions. Freightliner responded by developing models that balanced engine performance with chassis adaptability, ensuring that operators could meet varied operational demands. Vocational trucks represented another area of focus. These vehicles were customized for specialized roles, including construction, logging, refuse collection, and refrigerated transport. Each application demanded unique chassis configurations, cab options, and powertrain setups. Freightliner leveraged its experience in heavy-duty long-haul engineering while collaborating closely with Daimler-Benz to incorporate advanced diesel engines, durable transmissions, and lightweight materials. The result was a series of trucks capable of performing reliably in challenging environments while remaining cost-effective for fleet operators. Central to this diversification strategy was the expansion of modular design principles. Freightliner developed trucks with interchangeable components, allowing carriers to select configurations suited to specific needs. Cab layouts, frame lengths, suspension systems, and engine options could be tailored, enabling customization without sacrificing production efficiency. This modular approach not only reduced manufacturing complexity but also provided operators with vehicles optimized for performance, comfort, and operational economy. Fleet managers could specify features that maximized payload capacity, minimized fuel consumption, and improved driver ergonomics, reflecting a growing emphasis on operational efficiency in the industry. Dealer and service networks were critical in supporting this expanded product line. Medium-duty and vocational trucks required specialized maintenance knowledge as well as access to diverse spare parts. Freightliner extended its training programs to ensure that technicians could service a wider range of vehicles, from compact urban trucks to specialized vocational models. Parts distribution centers were upgraded to handle the increased variety, ensuring that operators experienced minimal downtime. By maintaining high service standards, Freightliner reinforced customer trust and encouraged adoption of the new product categories. Innovation in powertrain and materials accompanied diversification efforts. Diesel engines became increasingly refined, offering improved fuel efficiency, torque delivery, and emissions control. Aluminum and lightweight alloys were used extensively in medium-duty cabs and specialty chassis, reducing vehicle weight while maintaining durability. These technical advancements allowed operators to maximize payload without exceeding weight limits, a particular advantage in regions with stringent axle or bridge restrictions. Trucks could operate longer, faster, and more economically, meeting the practical needs of fleet operators. By the mid-1990s, Freightliner had successfully established a comprehensive portfolio that extended well beyond its original heavy-duty long-haul focus. The company offered vehicles capable of urban delivery, vocational service, and medium-range freight, each designed to address specific operational challenges. Customers valued the combination of reliability, customization, and service support, which allowed them to reduce costs, increase efficiency, and adapt to evolving market demands. Freightliner's reputation as a manufacturer of practical, innovative trucks was reinforced across multiple market segments. This period of diversification reflected a broader industry trend toward flexibility and specialization. Carriers sought vehicles that could meet diverse operational needs while maintaining low operating costs and high reliability. Freightliner's approach demonstrated that understanding the specific requirements of each market segment and designing trucks accordingly could create competitive advantage. The expansion into medium-duty and vocational markets positioned the company for sustained growth and reinforced its role as a comprehensive provider of commercial vehicles. By the end of the 1990s, Freightliner had become a multifaceted manufacturer, capable of producing heavy-duty long-haul trucks, medium-duty vehicles, and specialty vocational models. The company's investment in engineering, modular design, and dealer support ensured that each vehicle met high standards of performance, reliability, and efficiency. Product diversification not only broadened Freightliner's market presence but also prepared the company for the challenges and opportunities of the 21st century, solidifying its status as a leader in North American commercial trucking. Technological advances, aerodynamics, and efficiency. 1990s. By the 1990s, Freightliner had firmly established itself as a leading manufacturer of commercial vehicles across North America. However, rising fuel costs, growing environmental awareness, and intensifying competition demanded that truck design evolve beyond traditional engineering. Efficiency, once secondary to payload and durability, became a central focus. Aerodynamics emerged as a crucial factor, promising fuel savings, reduced emissions, and improved long-haul performance. Freightliner responded by incorporating streamlined design principles, advanced materials, and engineering innovations to produce vehicles optimized for both economy and reliability. The aerodynamic redesigns began with the cab and hood. Traditional trucks had relied on squared-off fronts and vertical surfaces, which generated significant air resistance at highway speeds. Engineers at Freightliner analyzed airflow patterns and worked to reduce drag through sloped hoods, integrated roof fairings, and side extenders. These modifications minimized turbulence around the cab and trailer gap, allowing trucks to maintain highway speeds using less fuel. The result was a measurable reduction in operational costs for long-haul carriers, particularly on routes covering thousands of miles per week. In addition to shaping the cab, Freightliner examined chassis components. Wheel covers, skirted fuel tanks, and underbody panels were introduced to smooth airflow beneath the truck. Suspension and axle designs were optimized to maintain clearance while reducing aerodynamic drag. Even minor details such as mirror placement and lighting housings were reconsidered to reduce wind resistance. This holistic approach reflected a growing understanding that every surface on a truck contributed to overall efficiency. By systematically refining each element, Freightliner could deliver trucks that were lighter, faster, and more economical to operate. Advances in powertrain technology complemented aerodynamic improvements. Diesel engines became more efficient through enhanced fuel injection systems, turbocharging, and electronic engine management. These changes allowed engines to generate the same or greater power while consuming less fuel. Transmissions were refined to match torque delivery to road conditions, reducing wasteful energy loss. Combined with aerodynamic refinements, these powertrain improvements enabled fleets to reduce fuel expenditures while maintaining performance on long hauls. Weight efficiency also played a critical role. Lightweight materials such as aluminum and composites were increasingly used in cabs, frames, and body components. Lighter vehicles not only required less power to move, but also allowed operators to carry greater payloads within legal weight limits. Freightliner's design philosophy emphasized the balance between strength and weight, ensuring that trucks could withstand rigorous commercial use without compromising efficiency. This approach reflected a broader trend in the trucking industry toward maximizing payload while minimizing operational cost. Another key aspect was driver experience. Ergonomics and comfort were integrated into aerodynamic designs to ensure that efficiency improvements did not come at the expense of usability. Tilting cabs, improved visibility, and climate-controlled interiors allowed operators to maintain productivity over long shifts. Streamlined designs reduced noise and vibration, further enhancing driver comfort and reducing fatigue. These considerations reinforced the notion that efficiency was not only mechanical, but operational, encompassing the entire driver-truck interface. By the mid-1990s, Freightliner's aerodynamic and efficiency-focused trucks had begun to transform the market. Fleet operators reported significant fuel savings, reduced maintenance costs, and improved uptime. The reputation of Freightliner as an innovator was reinforced, positioning the company as a leader in the emerging era of environmentally and economically conscious commercial transport. Aerodynamic design became a defining feature, setting a benchmark for competitors and shaping expectations for the next generation of trucks. This period also laid the groundwork for ongoing research into sustainability. Fuel efficiency, emission reduction, and driver-focused design became intertwined priorities that would influence engineering decisions into the 21st century. By embracing aerodynamic principles, optimizing weight, and refining powertrains, Freightliner demonstrated that innovation could address both operational needs and environmental concerns. The company's investments in technology during the 1990s positioned it to meet regulatory challenges, rising fuel prices, and evolving customer expectations, ensuring its continued leadership in the North American trucking industry. By the decade's end, the integration of aerodynamics and efficiency into truck design was no longer optional. It was essential. Freightliner's success in applying these principles highlighted the practical and economic benefits of technological innovation, solidifying its reputation as a manufacturer capable of adapting to a rapidly changing market, while maintaining performance, reliability, and profitability. The rise of fleet management and logistics integration, 1990s to 2000s. By the 1990s, commercial trucking in North America had become increasingly complex. Growing globalization, just-in-time supply chains, and rising customer expectations required fleets to operate more efficiently and reliably than ever before. The hardware of trucks, engine power, aerodynamic design, and weight efficiency remained critical, but technology now emphasized coordination and information as much as mechanical performance. Fleet management systems, logistics integration, and data-driven operations emerged as central components of modern trucking. Freightliner, already a leader in vehicle innovation, recognized that supporting operators required more than well-built trucks. It required tools to manage fleets, monitor performance, and optimize routes across an expanding national network. Early fleet management solutions were largely manual, relying on paper logs, radio communication, and operator experience to track vehicles, fuel usage, and maintenance schedules. As computing and telematics technology advanced, Freightliner and its customers began adopting electronic tracking systems. These systems collected data on speed, engine performance, fuel consumption, and vehicle location in near real time. Fleet managers could now identify inefficiencies, schedule preventative maintenance, and adjust routes to account for traffic or weather conditions. This data-driven approach reduced downtime, lowered operational costs, and increased delivery reliability, creating measurable advantages for fleets that invested in technology. Logistics integration followed naturally from fleet management. Companies increasingly sought to coordinate truck movements with warehouses, distribution centers, and customer demand. Freightliner supported operators by ensuring that vehicles could accommodate the specific requirements of integrated supply chains, from specialized trailers to weight-efficient configurations that maximized payload while complying with regulations. The combination of well-engineered trucks and advanced operational tools allowed carriers to deliver goods faster, with fewer errors, and at lower cost. In turn, this strengthened the role of trucking as a backbone of regional and national commerce, complementing rail and air transport. Communication systems also transformed operations. By the mid-1990s, satellite navigation, GPS tracking, and digital dispatch systems became more accessible to fleets. Freightliner trucks were increasingly equipped with onboard diagnostics and telemetry that linked drivers, mechanics, and managers. Real-time alerts on engine performance, tire pressure, or fuel levels allowed proactive maintenance and rapid response to mechanical issues. For operators covering thousands of miles weekly, these systems reduced uncertainty and improved reliability, reinforcing the economic value of modern trucks beyond traditional horsepower and load capacity. Driver management and safety were closely tied to these developments. Electronic logging devices replaced or supplemented paper logs, ensuring compliance with hours of service regulations while providing insight into driver behavior. Feedback loops allowed managers to monitor speed, braking patterns, and idle time, promoting safer and more efficient driving practices. By integrating these systems with vehicle telematics, fleets could improve fuel economy, reduce accident rates, and enhance operational efficiency. Freightliner's trucks were designed to accommodate these technologies, making adoption easier for operators and reinforcing the brand's commitment to performance and innovation. By the early 2000s, these systems had matured into fully integrated fleet solutions. Operators could coordinate dozens or hundreds of vehicles, optimize cross-country routes, and align schedules with real-time customer demand. The combination of durable, efficient Freightliner trucks and advanced management tools created a competitive advantage, enabling carriers to handle increased volume with precision. Companies that leveraged these capabilities experienced higher utilization rates, reduced maintenance costs, and improved customer satisfaction, highlighting the importance of technology in modern freight operations. The rise of fleet management and logistics integration also influenced truck design. Freightliner continued to innovate with modular cabs, adaptable chassis, and onboard electronic systems that supported telematics, GPS, and diagnostics. Vehicles were no longer judged solely on strength or payload. Integration with operational technology became a core selling point. This reflected a broader shift in the industry. Efficiency and intelligence mattered as much as raw mechanical performance. By the end of the 2000s, the combination of advanced trucks and integrated fleet management had transformed North American trucking. Freightliner's commitment to supporting operators through technology, in addition to engineering, positioned it as a partner in logistics, not just a manufacturer. The era marked a turning point in which trucking evolved into a data-driven, highly coordinated component of global commerce, setting the stage for further innovation in telematics, fuel efficiency, and automated systems in the decades to follow. Economic shifts and industry crises. 2000s. The 2000s were a decade of profound turbulence for the trucking industry, testing carriers, fleet operators, and manufacturers in ways rarely seen before. A combination of economic shifts, volatile fuel prices, tightening environmental regulations, and the growing pressures of globalization reshaped the industry. For Freightliner, these forces underscored the increasing importance of operational efficiency, technological integration, and strong service networks in maintaining competitiveness and supporting carriers through an uncertain market. The decade highlighted that success in trucking depended not only on durable machines, but also on the ability to respond strategically to rapidly changing circumstances, adapt fleet management practices, and implement innovations that could sustain performance under stress. At the start of the decade, freight demand remained relatively strong. Consumer spending continued to rise, fueled by economic growth and the expansion of e-commerce. Manufacturing output, increasingly tied to global supply chains, required more complex logistics and longer hauls. Trucks were expected to meet high standards of reliability and efficiency while operating under extended schedules and heavier workloads. Freightliner's vehicles, featuring aerodynamic designs, fuel-efficient diesel engines, and robust construction, were well suited to these demands. Operators increasingly relied on telematics, real-time vehicle monitoring, and routing optimization tools to reduce costs, manage schedules, and maintain service levels. Fleet managers began adopting data-driven strategies that combined performance tracking, predictive maintenance, and route planning, allowing them to reduce downtime, manage fuel consumption more effectively, and maximize operational efficiency across growing networks of trucks and terminals. Fuel price volatility quickly became a defining challenge. Between 2003 and 2008, crude oil prices rose sharply, sending diesel costs to unprecedented highs. For fleet operators, fuel quickly became one of the largest components of operating expenses. Carriers responded by reassessing routes, adjusting driver behavior, and carefully choosing equipment. Freightliner's emphasis on lightweight aluminum construction, aerodynamic enhancements, and fuel-efficient engines provided some relief. Yet, even with these advances, operating costs remained high, and profit margins were compressed. Companies implemented training programs focused on fuel-conscious driving, adjusted preventive maintenance schedules to preserve engine efficiency, and experimented with load optimization strategies to make every mile more cost-effective. The pressure to balance operational costs with service expectations forced fleets to innovate, implement new logistics practices, and monitor fuel consumption closely. Regulatory pressures further complicated fleet operations. The Environmental Protection Agency introduced stricter emission standards requiring selective catalytic reduction (SCR) systems and diesel particulate filters. Freightliner integrated these technologies without compromising performance, but compliance added complexity, higher initial costs, and increased maintenance demands. Fleet managers were tasked with balancing regulatory requirements with operational productivity. Drivers and maintenance teams had to be trained, compliance logs maintained, and vehicles regularly inspected to ensure adherence to both federal and state standards. These challenges demanded careful planning and constant monitoring, particularly for operators managing larger fleets or international routes. The financial crisis of 2008 to 2009 intensified pressures on the industry. Industrial output contracted, consumer spending fell, and freight volumes declined sharply across the United States. Many carriers scaled back operations, delayed truck purchases, or exited the market entirely. Freightliner's established reputation for reliability, service support, and technological integration enabled the company to retain critical customers while supporting operators navigating reduced demand. The crisis emphasized trucking's sensitivity to macroeconomic cycles, highlighting the need for operational flexibility, strategic planning, and financial resilience. Globalization added further complexity. Expanding trade with Canada, Mexico, and overseas markets required trucks capable of long-haul efficiency while meeting diverse regulatory standards. Freightliner's vehicles, equipped with telematics and compliance monitoring systems, allowed operators to maintain productivity across domestic and international routes. The decade highlighted the growing importance of integrated solutions, combining vehicle performance, logistical intelligence, and dealer support. By the close of the 2000s, the industry had adapted to a landscape defined by high fuel costs, economic recessions, complex regulations, and global trade pressures. Freightliner responded with advanced, fuel-efficient trucks, expanded dealer networks, and service programs designed to support operators under challenging conditions. The decade demonstrated that success in trucking required more than reliable machinery. It demanded flexibility, technological adaptation, and operational foresight. The lessons learned during this era shaped Freightliner's strategies, ensuring the company remained a central figure in both American and international freight transport. The 2010s marked a new era for Freightliner, defined by technological advancement, regulatory adaptation, and an intensified focus on operational efficiency. Following decades of incremental innovation, the company entered the decade determined to consolidate its position as a leader in North American trucking by integrating advanced engineering, aerodynamics, fuel efficiency, and driver comfort into a single platform. The result was the Cascadia, a model that would redefine expectations for performance, sustainability, and operator experience in the heavy-duty segment. Introduced in 2007, the Cascadia underwent significant refinement in the 2010s, reflecting the decade's economic pressures, stricter emissions standards, and shifting customer expectations. The trucking landscape had changed dramatically. Rising fuel costs, increasingly stringent Environmental Protection Agency regulations, and growing concern over carbon emissions had made efficiency a priority. Freightliner engineers responded with a holistic approach, combining lightweight aluminum construction, improved aerodynamics, and optimized powertrains to reduce fuel consumption without sacrificing payload or reliability. The Cascadia incorporated features such as roof fairings, side extenders, underbody panels, and chassis optimization to minimize drag, achieving measurable improvements in fuel efficiency across highway and regional routes. Technology became a central component of the Cascadia's design. Telematics systems were fully integrated, allowing fleet operators to monitor real-time vehicle performance, anticipate maintenance needs, and optimize routing. Engine data, brake diagnostics, and fuel consumption metrics could be analyzed remotely, giving managers the tools to enhance fleet productivity while reducing downtime. Onboard diagnostics were paired with predictive maintenance programs, enabling proactive service interventions and lowering the likelihood of costly breakdowns. For drivers, these systems improved operational transparency and simplified routine tasks, contributing to both safety and convenience, and reinforcing Freightliner's reputation for reliable, user-friendly vehicles. Regulatory compliance continued to influence design choices. The EPA's 2010 emission standards required selective catalytic reduction (SCR) and diesel particulate filter technologies, compelling manufacturers to balance performance with environmental responsibility. Freightliner integrated these systems efficiently into the Cascadia platform, ensuring engines met emissions requirements while maintaining torque, horsepower, and reliability. The company's ongoing collaboration with fleets facilitated training and guidance on operating vehicles under new regulatory frameworks, reinforcing its reputation for support beyond the showroom. In addition, Freightliner increasingly emphasized sustainability programs, helping operators reduce their carbon footprints and improve corporate responsibility metrics, which also became critical for fleets serving environmentally conscious clients. Driver comfort and ergonomics were central to the Cascadia's success. Long-haul trucking demanded a cab that minimized fatigue and maximized usability. Freightliner redesigned interior layouts with improved seat ergonomics, noise reduction, and visibility. Controls were centralized and intuitive, and cab space was optimized to accommodate rest periods during extended trips. Refrigeration units, climate controls, and additional storage options were integrated to improve living conditions for drivers on long routes. By addressing the daily experience of drivers, Freightliner strengthened operator satisfaction and retention, a factor that directly influenced fleet productivity, efficiency, and safety. Fuel efficiency became a defining selling point. Rising diesel prices and the growing emphasis on sustainable operations pressured fleets to adopt vehicles capable of reducing costs per mile. The Cascadia's combination of aerodynamic enhancements, efficient engines, and lightweight construction enabled operators to improve fuel consumption by measurable margins compared to older models. Fleet managers could integrate these savings into broader logistics strategies, including route planning, load optimization, and driver scheduling. The synergy of engineering, technology, and operational insight positioned the Cascadia as a centerpiece of modern freight operations, a model that other manufacturers would soon emulate. By the close of the 2010s, the Cascadia had cemented its role as Freightliner's flagship heavy-duty truck. It embodied a philosophy that combined efficiency, sustainability, operator comfort, and technological integration. The decade demonstrated that success in modern trucking depended on a multifaceted approach: reducing operating costs, complying with evolving regulations, leveraging telematics and predictive analytics, enhancing driver experience, and maintaining a competitive edge in an increasingly globalized market. Freightliner's focus on these elements ensured that it remained at the forefront of North American freight transport, ready to meet the challenges of a rapidly changing industry while setting new standards for efficiency, safety, and innovation. The Cascadia was more than a truck. It was a symbol of Freightliner's ability to respond to economic pressures, technological evolution, and operational demands, proving that careful integration of design, performance, and service could shape the future of the industry. The 2020s continue to challenge Freightliner with technological, regulatory, and market pressures, but the company's strategy has emphasized innovation without compromising reliability. Through electrification, automation, and digital integration, Freightliner is shaping a future in which freight transportation is safer, cleaner, and more efficient. The company's trajectory demonstrates that the next generation of trucks will be defined not only by horsepower and payload, but by intelligence, sustainability, and the ability to meet the evolving needs of operators, fleets, and society at large. As the decade progresses, Freightliner remains a central figure in redefining what modern trucking can achieve.